This is Saritha, working as an assistant professor in the Department of ECE, Institute of Aeronautical Engineering. So today's session I am going to explain about definitions and terminologies based on module 3, that is image enhancement. So in this module we are having point processing technique, and in this point processing technique we are having different types of point processing techniques are there: contrast stretching, bitplane slicing, and image negative. So here next one is histogram processing. With the use of this histogram processing, we can increase the image quality and increase the contrast of an image, and spatial filtering, enhancement in frequency domain, image smoothing, image sharpening. Here in this point processing technique, what is mean by point processing? So what is mean by point processing means here, consider one image. So the image size is representing with m into n. So in this image we are having number of pixels. I am applying the transformation function on this particular pixel. The resultant image is stored in same location of the target image. So same location of the target image. So in this point processing technique, we can apply the functions on point to point. So the image size is representing with m into n. So I am applying the transformation function on this particular pixel or this pixel. Here the resultant is, this is my original image, f of x comma y, x and y, f of x comma y. This is my resultant image. I am applying the transformation function of f of x comma y. The resultant is f of u comma v, or g of x comma y. So g of x comma y, g of x comma y. Here I am applying the function here, transformation here. The resultant is stored in same location of the target image. So this is the point processing technique. So what is mean by image enhancement? Define in image enhancement. This image enhancement is the procedure of improving the quality and information content of original image. And with the use of this enhancement, we are applying the transformation functions. And filter function in our original image. We can improve the picture quality, so that image is more suitable for the specific application compared to the original image. And the second one is, what are the primary and secondary colors? So when we go for image processing, first we required image. We need image. So in that image we are having a color image and black and white image. So when we go for black and white image, we are having black and white colors only. So in that, the black color we are representing the gray level is 0, and white color we are representing the gray level is with 1. In this we are having primary and secondary colors. Primary colors are red, 3 primary colors, red, yellow, blue, and the secondary colors are orange, green, and violet. So here, what is spatial domain? The spatial domain is the normal image space in which a change in position in I, the directly projects to a change in position in S. So here define point processing. So in this point processing, where f of x comma y is the input, already I explained here. So here in point processing technique, f of x comma y is the input image, and we are applying the transformation function. T, transformation function of f of x comma y. Here the output is g of x comma y. Here whatever the we are applying the function on this, So the resultant stored in same location. So the point processing where f of x comma y is the input image and g of x comma y is the processed image and t is point operator defined over some neighborhood of x comma y. So what are the two properties in linear operator? So in this linear operator, a function f is called a linear operator if it has the two properties. F of x comma y is f of x plus f of y for all x and y. F of cx equals to c f of x for all x and all constant c. All constant c. Here, how many number of steps are involved in image processing? So, how many numbers of steps involved in our image processing? In this image processing, first step is image acquisition, second one is image enhancement, and third one is image restoration and color image processing and wavelets and multi-resolution processing, compression, morphological processing and processing segmentation, representation and description, object recognition. So here in our subject we are having image acquisition, transforms, enhancement, compression and segmentation. So segmentation and compression. So what is concept algebraic approach? So here the concept of algebraic approach is to estimate the original image which minimizes a predefined criterion of performances. So the concept of algebraic approach is to estimate the original image which minimizes a predefined criterion of performances. So in this the primary colors are red, green and blue and the secondary colors are yellow, orange, yellow and violet. Here in this, what is concept of algebraic approach? The concept of algebraic approach is to estimate the original image which minimizes a predefined criterion of performances. So define object recognition. So how to detect the object? So the recognition is the process. So assign a label to an object based on its descriptors. So here we conclude our coverage digital image processing with the development of methods for recognition. So in object recognition of individual objects. What is contrast stretching? So in this contrast stretching, when we go for improve the image quality in our point processing technique, one is contrast stretching. So in this contrast stretching, so here in this we are having, this is T1 of R, T2 of R, T3 of R. Here the transformations are T1 of R, T2 of R, T3 of R. Here range is from here 0 to L minus 1. So minimum range is from 0 to L minus, minimum is 0 and maximum gray level value is L minus 1. In this we are representing R1, R, R1, R2. Here R, R1, R2. 0, 0 is the minimum gray level. L minus 1 is the maximum gray level. L minus 1 is the maximum gray level. Here the transform from 0 to R. Here T1 of R 0 less than or equals to R. So the entire range we are representing with R. Here it is R1. Here it is R2. The maximum range we are representing here L minus 1. The maximum range we are representing with here L minus 1. So here the transform function T1 of R0 less than or equals to R less than R1. So here T2 R1 less than or equals to R less than R2. In T3 R2 less than or equals to R less than L minus 1. So this is the contrast stretching. So in this we are having R1, if R1 equals to R2, then S1 equals to 0, S2 equals to L minus 1. Here R1 equals to R2, S1 equals to 0, S2 equals to L minus 1. So in this we are representing S1, S2. So if R1, R2 both are same, then S1 equals to 0 condition and S2 is the L minus 1 means maximum gray level value. So the transformation becomes a thresholding function that creates a binary image that is in contrast stretching if R1 equals to R2, S1 equals to 0 and S2 equals to L minus 1. Here, what are the two methods of algebraic approach? Constraint method or unconstrained restoration. So in this we are having unconstrained restoration approach and constraint restoration approach. And 11th one is what is transformation linear function. Here the location of points in the transformation function R1 S1, R2 S2. If R1 equals to S1 and R2 equals to S2, the transformation is a linear function that produces a no change in gray level. So in this transformation of linear function, if R1, here I am representing R1. In this section R1, so S1, S2, R1, R2. If R1 equals to S1, so here linear transformation, whatever the input we are applying, we are getting same output. There is no change in gray level. So here there is no change in gray level. So linear function, the transformation in linear means the here R1 equals to S1 and R2 equals to S2. Then the transformation is a linear function that produces a no change in gray levels. And how to transformation becomes a thresholding function. How transformation becomes a thresholding function. Here the transformation becomes a thresholding function that creates a binary image. So here in contrast stretching R1 equals to R2 means S1 equals to 0, S2 equals to L minus 1. So in this binary image, when we go for in thresholding function, for example, consider one image. So in this image, 8, 32, 64 for 128, 3, 32, just example here, 8, 8. So in this image, so find the two, this is the gray level value converted into binary form means, observe here, consider a threshold value. Here the threshold value is, for example, I am assigning the threshold value is 32. So whose pixel values are less than or equals to 32, then represent with 0, greater than 32 represent with 1. Here 32 is whose pixel values are greater than or less than or equals to 32, we are representing with 0, and greater than 32 represent with 1. So this is with the use of thresholding, we can convert the gray level image into binary image. So in this transformation also, the transformation becomes a thresholding function. So thresholding function is a linear variation. There is no change in our gray levels. And define gray level interpolation. So in this gray level slicing, and bit plane slicing, Here, in gray level, interpolation deals with assignment gray levels to pixels in the spatially transformed image. So, observe here in gray level slicing, this is the maximum gray level L minus 1. Here is 0, A, B. This is X. Here it is X1. Here it is X2. Here S. Here representing with R. If the range between 0 to A, what about S? 0 to A, S equals to X1. For example, A to B, the region is from, next region is from A to B, then S equals to X2. If the region B to L minus 1, here the region B to L minus 1, here it is S equals to X1. So, when we go for a gray level, apply the gray level slicing. So, here it is 0, R, S, A, B. It is the maximum level. Here 0 to A, S equals to R, and B to maximum length L minus 1, here S equals to X2. So here this is the representation of gray level slicing. Here in gray level interpolation deals with the assignment of gray levels to pixels in the spatially transformed image. And next one, how to create a binary image. So in this we need to consider the threshold value whose pixel values are greater than if we are assigning some threshold value, if whose pixel values are less than or equal to that gray level value represented with 0 and remaining pixels represented with 1 means that is a binary image only. Here, if R1 equals to R2, S1 equals to 0 and S2 equals to L minus 1, the transformation becomes a thresholding function that creates a binary image. Here, R1 equal to R2, then outputs are, we are representing with R is the input, S is the output. Here S1 equals to 0, S2 equals to L minus 1 means, S1 equals to 0 means that is the minimum gray level. So that is black. S2 equals to L minus 1 means that is maximum gray level value. So minimum gray level value we are representing with 0 and maximum gray level value we are representing with L minus 1. And what is meant by noise probability density function? Here, the spatial noise descriptor is the statistical behavior of gray level values in the noise component of the model. Define gray level slicing. So, in this gray level slicing, highlighting a specific range of gray level in an image often desired in a gray level slicing. So, in this gray level slicing, so here the regions are 0 to A to B and B to maximum gray level value L minus 1. So, define sharpening of an image. So, sharpening of an image, in this we are using high pass filter. With the use of high pass filter, it gives the sharpening of an image. Image sharpening refers to any enhancement technique that highlights the edges and fine details in an image. So, with the use of high pass filter, so in high pass filter, so if we are assigning some cutoff frequency, it allows those frequencies only. With the use of this high pass filter, high frequencies means it gives the sharpening of an edges of an image. So, what is image translation and scaling? So, image translation means reposition the image from one coordinate location to another along straight line path. Next one is, what is image sharpening process? So in this image sharpening process is an effect applied to digital image to give them a sharper appearance. So for this sharpening process, we can go for high pass filters. With the use of high pass filter, it gives the sharpening of an edges of an image and define the second order derivative of a digital function. So in this second order derivative function, with the use of these functions, it scans the vertical and horizontal lines of an image. So in the derivative, second order derivative functions, we are represent dou f by dou x. It scans the vertical, and dou f by dou y, it scans the horizontal lines. Dou f by dou x plus dou f by dou y, it scans both vertical and horizontal lines of an image. And what is mean by unconstrained restoration? So the noise n, a meaningful criterion function, is to seek an function f. Seek f is a function such that h is the approximate in a least square sense by assuming the noise term is as small as possible, is known as the least square error approach. Define differentiation. So in this differentiation, sharpening is the process. So performs a differentiation on the pixels to sharpen the image. What is image differentiation here? So here image differentiation enhance the edges, discontinuous, and de-emphasize the pixels with slow varying gray levels. And next, what are the three methods of estimating the degradation function? Observation, experimentation, and mathematical modeling. So in estimation or degradation function means when we go for how to restore our original image. So how to restore our original image means after enhancement, our original image properties can be changed. So how to recover our original image means, for that purpose we can go for degradation function. In the degradation function, how to recover our original image means with observation, or we are applying some experimental we need to apply some function on that image, then we'll get our original image. And another method is mathematical modeling. So we are applying some transformation function or mathematical functions on that image, we will recover our original image. So in that, first one is observation, second one is experimentation, and third one is mathematical modeling. Define enhancement and write examples. So enhancement technique is based primarily on the placing aspects in might present to the viewer, for example contrast stretching. Define Butterworth filter. So in this, Butterworth filter is a type of signal processing filter designed to have a frequency response as flat as possible in the pass band. So in this Butterworth filter, so with the use of this Butterworth filter, we are having low pass Butterworth filter and high pass Butterworth filter. So with the use of this Butterworth filter, we can remove the noise in our original image. So what is mean by band pass filter? So band pass filter, within that band only. Band pass filter and all pass filter means it allows all frequency, and band pass filter we are assigning some particular band. The signals are passes in the particular frequencies only, in certain range only, and remaining ranges it detects a signal. In this band pass filter, whatever the range is there, we are assigning some frequency from 10 Hz to some 100 Hz. It allows whose pixels are having in that range, it allows those frequencies only, and it attenuates the remaining frequencies. A band pass filter or BPF is a device that passes frequencies within a certain range and rejects frequencies outside that range. And next one is define low pass filter. So what is mean by low pass filter? With the use of this low pass filter or smoothening or average filter. So here in our image processing, smoothening of an image, average filters, and low pass filter. These three are, we are applying, these three are gives the image is smoothening of an image. So with the use of low pass filter, we are applying the low pass filter in any image, it gives a smoothening of an image. If we are applying the average filter on image, it gives the if in this average filter the mask size is increased, then mask size is increased, image gets blurred. So the output of the average filter, the images gets blurred, the quality is reduced. And in low pass filter, what is meant by low pass filter means we are assigning some particular frequency. It allows whose signals are having that frequency only it allows and attenuates the remaining frequencies. Means here we are assigning some cutoff frequency. So between that, for example, here also we are assigning in thresholding technique. In thresholding technique, we are assigning some value. So whose pixel values are between that range, it allows, and remaining are representing with 0. So like that here in low pass filter also, a low pass filter attenuates a content above a cutoff frequency, allowing lower frequencies to pass through the filter. Define high pass filter. So in this high pass filter, we are representing this way. Here, a high pass filter attenuates content below a cutoff frequency, allowing high frequencies to pass through the filter. What is image negative? So, in one important term in our image enhancement, it is image negative. So, in this image negative, input is R, output is representing with S. In this image, here S equals to L minus 1 minus R. Here 0 and maximum gray level value is 1. 0 is the minimum gray level, L minus 1 is the maximum gray level. For example, here condition S equals to L minus 1 minus R if input R is 0. What about our output? S equals to L minus 1 minus 0. S equals to L minus 1. Here, if input is 0, then output is maximum gray level value. Here it is R, here it is S. For example, R equals to L minus 1. What is our formula? S equals to L minus 1 minus R value is L minus 1. S equals to 0. Image negative is nothing but if we are applying 0 input, then output is maximum, negative. If input is maximum, L minus 1, then output is 0. So, in this case, we are considering S equals to L minus 1 minus R. If R equals to 0, this term is 0, S equals to L minus 1. If R equals to L minus 1 cancel, then S equals to 0. This is the image negative. So, in this, for example, graph in straight way. So, in this way, the graph representation is like this. Here it is L minus 1, 0. Here it is S, here it is R. Here, whatever the input is there, whatever input image, but output is pure white only. For example, the graph is in like this. RS. Whatever the input we are applying, we are getting same output. So, this is the image negative. The negative of an image with gray levels in the range 0 to L minus 1 is obtained by using the negative transformation, which is given by the expression S equals to L minus 1 minus R, where S is output pixel, R is input pixel. Define intensity. So the principal objective of sharpening to highlight transition is called intensity, or the principal objective of sharpening to highlight transition is intensity. So what is the formula for image negative and log transformation? So for image negative is S equals to L minus 1 minus R, and log transformation function S equals to C log 1 plus R, where C is the constant and greater than or equal to 0. So with the use of this log transformation, no need to consider entire image to analyze the image. So consider any one part of that image, we can analyze the entire image. So with the use of log transformation, no need to consider entire image. So I consider some portion of that entire image, apply some transformation function in that particular part, and we will get the resultant for entire image. So that is the basic advantage with the use of this log transformation. And bitplane slicing. So in this bitplane slicing, it is also one technique in our point processing. With the use of this bitplane slicing, for example, number of pixels are there. So each pixel consisting of 8 bits. 8 bits here, 0 to 7. So bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. In all the pixels we are having bit 0 to bit 7. B0, B1, B2, B3, B4, B5, B6, B7. If I am applying the bitplane slicing, it changes the bit of in all the pixels, 7th bit of all the pixels. If I am applying the bitplane slicing on 6th bit, it changes the 6th bit in all the pixels. B5 change the bits in all the pixels. B4 change the bits in all the pixels. In B3 also change the pixels in change the bit position in all the pixels. It's like bit 2. So we are applying the function on each and every bit of all the pixels at a time. So in this bitplane slicing is a method of representing an image with one or more bits of the byte used for each pixel. So next one is why blur is to be removed from images. So why blur is to be removed from the images means when here image is not clear. When camera is motion position, then capturing is not clear means the image gets blurred. If we are removing those blur noises in our image, the picture quality is good. So the blur is caused by lens that is improper manner, relative motion between camera and sense and atmospheric turbulence. So it will introduce the bandwidth reduction and make the image analysis is complex. So to prevent the issue, blur is removed from this image. And what is meant by image restoration? So restoration attempts to reconstruct or recover an image that has been degraded by using a clear knowledge of the degradation phenomena. So in this degradation purpose, we are having 3 methods. One is observation and experimental and apply the mathematical model. So with the use of these 3 functions, we will recover our original image. And what are the 2 properties in linear operator? So in this we are having 2 properties, additive and homogeneity property. And how a degradation process is modeled. So a system operator H, which together with an additive white noise term x comma y, A operates on an input image f of x comma y to produce a degraded image g of x comma y. So in this enhancement we are having statistic order filters also there. So statistic order filters are minimum filter, maximum filter, and minimum, maximum, and median filter. So with the use of these filters, so consider any image, so pixel values 10, 2, 5, 4, 7, 8. So write in a order 2, 4, 5, 7, 8, 10. So in this minimum value is 2. So with the use of this minimum filter, in that entire image, which part is a dark. So with the use of minimum filter, it found the darkest point in our image. And maximum filter, this is maximum filter, means it gives the maximum gray level value in an image, means it gives the brightest point in our image. So it found the brightest point in our image. What is median value? So with the use of median value, we can remove the salt and pepper noises in our image. So salt and pepper noises are important. Here salt noise is nothing but it is salt and pepper noises. So these noises are representing 0, minimum gray level and maximum gray level. Minimum and maximum gray level. So these noises are 0 or 0 and maximum. So with the use of this median filter, whatever the pixels are there, those pixels we can arrange in a median. All pixel values are in the same manner. The neighboring pixels and adjacent pixel, all pixels are gray level values are near to each other. There is no salt and pepper noise. For example, if consider one image, here this is 256, this value is 30. This value is 30. So here, and remaining pixels are 60, 54, 40 or 35. So compare this adjacent and neighbor pixels are gray level values are near to each other except this 256. So with the use of median filter, we can remove that salt and pepper noises. So these are the statistic filters involved in our image enhancement: minimum filter, maximum filter, and median filter. With the use of minimum filter, it finds the dark point in our image. In maximum filter, it finds the brightest point in an image. In median filter, it removes the salt and pepper noises of an image. And define homogeneity property in a linear operator. The homogeneity property says that the response to a constant multiple of any input is equal to the response to that input multiplied by the same constant. Define circular matrix. So a square matrix in which each row is a circular shift of the preceding row and the first row is a circular shift of the last row is called the circular matrix. What is concept of algebraic approach? The concept of algebraic approach is to estimate the original image which minimizes the predefined criterion of performances. So up to here, the definitions and terminology of a third module is over. So in this, the basic points are point processing. Point processing techniques. In this, we are having image negative, contrast stretching, and bit plane slicing, and histogram technique. So with the use of histogram technique, we can improve the image quality. We can increase the contrast of an image. And next one is in frequency domain filters. In that frequency domain, we are having Butterworth high pass filter and Butterworth low pass filter, Gaussian high pass filter and Gaussian low pass filter, and statistic filters, order statistic filter. In this order statistic filter, median filter, maximum filter, and minimum filter and minimum filter. So with the use of this image enhancement, we can improve the picture quality. That image is more suitable for the specific application compared to the original image. And after this enhancement, we will ask some features of an image. If we are applying the average filter, then what will happen? The resultant image gets blurred. So image quality is reduced. And if you are applying some filters, some functions, the original image quality is reduced and salt and pepper noises are added, and ringing noise is also added. With the use of Butterworth and median filter, we can reduce the ringing noise and salt and pepper noises. And how we can recover our original image means with the use of degradation function. So in this, with the use of degradation function, we will recover our original image. How to recover our original image means, in that we are having three models: observation, experimental and mathematical. If you are applying first observation, our image is not recovered, then go for experimental method. And in experimental method, if we recover our image, it is okay. Otherwise, go to the mathematical method. So with the use of these all, we'll get our original image. And here one more concept is filter mask. Here mask is representing with 1 by 1 or 3 by 3 or 7 by 7, 5 by 5. So depending on sub image, we are applying the filter mask. So the filter mask here 3 by 3 means W1, W2, W3, 4, W4, W5, W6, W7, W8, W9. We are applying this filter mask on our sub image. So each and every pixel of filter mask superimposing on the sub image. The resultant is stored in center pixel of an image. So this is the point processing technique. This is the filter mask operation. And when we go for in point processing technique, that image is m into n, that is f of x comma y is our image, and we are applying the transformation function of this f of x comma y. Then output is g of x comma y. So the resultant is stored in same location of the target image. So this is the point processing techniques, and these are the topics involved in our third module. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.